transition elements. The next one, draw the label diagram to represent the structure of metallic bonding. How to represent the metallic bonding? You can draw positive ions, in sea of delocalized electron. Then you can earn 1 mark if you have this diagram, and they're asking for label diagram. So you have to label this as cations, and this is delocalized electron, or at least as electron. Delocalized electrons. And this area you can just write sea of electron. At least you have to have these two to get the second mark. Hope you understood that how to get the mark also. When it is asked the label diagram, then you have to definitely label the diagram, unless you can't get the full mark. And move on to the next question. Iron is an essential element to the human body. It's a part of hemoglobin which help to transport oxygen. People with insufficient amount of iron in their dietary supply face to anemia condition. Such people are treated with extra iron containing syrup or tablet. Thomas, a scientist in chemical laboratory, he prepared an iron syrup solution by dissolving 8.7 gram of iron to acetate and prepare 100 centimeter cube of solution. Find the concentration of acetate. It's a 3-mark question. First of all, you need to find the MR of the acetate, iron acetate. You get 1 mark for that. That is 56 for iron, plus carbon is 12 plus 1 into 3 for the CH3 part, and carbon again 12, oxygen 16 into 2. All together multiply by 2 for this formula. Then we'll find the answer. 12 in 12 plus 3 plus 2 plus 2 plus 6. Answer is 174. You get 1 mark for this answer. Then you can find moles. Then it's mentioned that 8.7 over 174. But even you haven't shown that how to find the MR as 174. In this case, if you have written here 174, then you will get the both marks. 8.7 divided by 174 is 0.05. 0.05 moles. And then the concentration you can get, concentration equal moles over volume. Moles is 0.05. Volume is given as 100 centimeter cube, that means 0.1. So it is 0.5 mole per decimeter cube. So answer is 0.5. You get 1 mark for this, and 1 mark for this, and this other mark for this. This is how you can earn 3 marks for this question. Hope you understood how to solve the question on question. Then move on to the next one. Calculate the concentration in milligram per decimeter cube. We took the concentration as 0.5 mole per decimeter cube. Mole per decimeter cube you can convert into gram per decimeter cube by multiply with mR. Then it is 28 gram per decimeter cube. Gram, milligram, you multiply by 1000. So it is 28,000 milligram per decimeter cube. Right? The answer should be 28,000. Doctor recommended 5 centimeter cube of iron syrup to consume on each day. Calculate amount of iron taken by children with each dose, right? So it is 28,000 per decimeter cube means in 1000 centimeter cube, you have 28,000. If it is 5 centimeter cube, how much? Then it is 140 milligram per day. $140 milligram. Hope you understood that how to answer this question. Then we'll move on to the next question. Third question. Four separated food dyes, C, D, E, and F are mixture of food dyes. And a mixture of food dye X were investigated using the paper chromatography. Draw a label diagram to carry out the experiment, right? This is also label diagram. First of all, you need to draw the diagram. Here you have the beaker and chromatography paper in it. Then this is the solvent level, and here is the baseline. On this baseline, you have to have spots A, C, D, E, F, and X. It's better having much bigger diagram. Right, and this is closed. Okay, then you have to draw this diagram. You get 1 mark for the basic diagram, and this solvent level should be below the pencil line. You get the 2nd mark for that. And you get 3rd mark for the labeling. This is the beaker. This is the chromatography paper or filter paper. And this is the baseline or starting line, and this is solvent. At least you have to have this one, chromatography paper, this one, to get the 3rd mark. First of all, you get the mark for the basic diagram, and 2nd mark if the solvent level is below the baseline, and the 3rd mark is for labeling these two at least. Why should water level below the food dyes? The answer is, if the water level is contacting with food dyes, then food dyes will dissolve to prevent the dissolving of food dyes in the solvent. If it is dissolving, then you can't get the moving of the food dyes. During the experiment, water rises up the paper. The experiment is stopped just before the water reached to the top of the paper. The diagram shows the paper after it has been removed and dried. Which food dyes C, D, E, and F does X contain, right? Then look at the X has two dots. And you can see that this dot is parallel with this dot of the C. So this has C. And this dot is parallel with this one. So it has D and well as well. C and D are the substances that contain in food dyes. Why suggest why food dye F didn't move over the paper? Anything which is not moving on the paper, in order to move the dye over the paper, what should be happen? It should be soluble in water. As it is not soluble, so it is not moving, right? So F is not soluble in the solvent. Or here water is used, so it's not insoluble in water. Next question. In a separate experiment, a sample of food dye was analyzed to determine amino acid present in the sample. The chromatography procedure is carried out as usual, but no spot were detected. Explain the practical procedure to observe spots of amino acid on the chromatograph paper. Right, then the spots are not visualized. You must know the reason. The amino acids are colorless, so you can't observe the spots. First of all, what do you have to do? Number one, dry the paper after the chromatography. Then, number two, add the locating agent. Locating agent is ninhydrin. You don't need to mention the name of the locating agent. Just it's enough, right? Mention add the locating agent and dry the paper again, right? Dry the paper, add locating agent and dry the paper again. Then you will observe the spots of amino acid. So you can calculate the RF value.